Many people see addiction as a problem of personal weakness. In this view, addiction often begins as a search for self-gratification and continues because a person is unwilling or unable to stop. But the idea that pleasure-seeking alone drives addiction has fallen by the wayside. We must ensure that addiction is no longer seen solely as a problem of personal weakness or lack of willpower. Instead, addiction is recognized as a complex disease that can arise from various factors, including genetic, environmental, and behavioral factors. While pleasure-seeking can contribute to addiction, it is essential to note that addiction involves brain changes beyond simply seeking pleasure. Addiction is characterized by a compulsive drug-seeking behavior, even in the face of negative consequences. This suggests that addiction involves the brain's reward circuitry and the brain's systems for motivation, decision-making, and self-control. Research has also shown that addiction is a chronic and relapsing condition, similar to other chronic diseases like diabetes or hypertension. Like these other diseases, addiction requires ongoing treatment and management to achieve and maintain recovery. Addressing addiction as a public health issue rather than a moral failure to provide effective treatment and support for those struggling is essential. A second major shift in thinking has come from the combined findings of several branches of science, which have shed light on the biological influences that play a role in addiction. Over the past few decades, neuroscience, genetics, and psychology advances have helped researchers better understand the biological influences contributing to addiction. One important finding is that addiction involves brain reward system changes. When a person engages in pleasurable activities like eating or having sex, the brain releases dopamine. This neurotransmitter helps us experience pleasure and reinforces behaviors that promote survival. Drugs of abuse also activate the brain's reward system, flooding it with dopamine and leading to feelings of euphoria. Over time, the brain adapts to this increased dopamine activity, leading to a reduced response to natural rewards and an increased drive to seek out drugs. In addition to changes in the reward system, addiction is also associated with changes in other brain areas, such as the prefrontal cortex, which is involved in decision-making and self-control, and the amygdala, which is involved in emotional processing. Genetics also play a role in addiction, with specific genes increasing the risk of developing an addiction. Environmental factors, such as stress, trauma, and social influences, can also contribute to the development of addiction. Understanding the biological underpinnings of addiction has important implications for treatment and prevention. For example, medications can target specific neurotransmitter systems involved in addiction, and behavioral therapies can help individuals develop coping skills and strengthen their self-control. Addressing the biological, psychological, and social factors that contribute to addiction can improve outcomes and support individuals in recovery. Matthew, a cancer and stroke survivor, requests that you help spread awareness of severe diseases by publishing this video. Please take a moment to subscribe to and like this video.